Okay. It's starting.
All right, you guys. So we're doing a remote learning because it looks like we're not going to be back in school for this year. So I got to give you guys remote assignments. I thought I would try to do some videos of me explaining the material. So I'm going to do this. Now what I'm going to do here, the first two problems, I'm going to do a couple of problems from the material that I just did assign to you that's already been due, that you've had for a little while to do. Those are the adding and subtracting the rational expressions here. So I'm going to do just one example of each, just so it's fresh in your mind, and then I'm going to move on to the new material, which is actually a little bit easier, I would say. The new material. If you had a little trouble with this, with these numbers as the denominators got kind of crazy like this, like they're binomials and stuff like that. Trinomials even. There's a trinomial there. So if that was confusing to you, try to pick up on this next thing I'm going to teach, because I think it's going to be quite a bit easier. I think you'll be able to understand it a little bit better. The problems aren't going to be quite as involved. So actually the concept's very much similar, but the problems are going to be a little bit easier. So just so you know. But I'm going to do, these are two problems just like the last couple of homeworks that I gave you. I'm just going to do some example problems. So first one is -3 over x squared minus 2x plus 5 minus 15 plus 4 over x plus 3 plus 3 over x plus 5. How do we add those together? Well, there are three fractions. When you're adding fractions or subtracting fractions, you need a common denominator. So the first thing we have to do is figure out the common denominator. That turns out to be the least common multiple of all the denominators. So what you first have to do when you're adding or subtracting fractions or rational expressions, you need to find the common denominator. So that means factor all of the denominators. This guy will factor, so let's factor it. It factors into x. Two things that multiply to be 15 and subtract to be 2. That would be 5 and 3. This tells me same signs, both of them. No, I'm sorry, not same signs. Different signs minus different signs. The bigger one is negative. So 5 is negative, 3 is positive. This guy factors down into that. So what we want to do, these guys are already factored. And by chance, look, x plus 3, x minus 5. This guy happens to factor down into this times this. What are the chances? Oh my gosh, the luck is with me today.
It's almost like you planned it that way.
Almost. Oh yeah, almost forgot. These problems come from a textbook. Okay, is that going to happen in the real world? Probably not. Okay, but anyways, just enjoy it while it lasts. Okay, so here we go. Now, I need to create a denominator. This is the key. Watch. I need to create a denominator that contains all of these guys, but I like it to be as small as possible. That's going to be the least common multiple of all these denominators. Well, here's how I create a denominator. I take one of the denominators, say this guy, and I put the whole thing, because if it doesn't have either one of these two, it's not going to contain this guy. I need this entire denominator right here, so I need both of these, okay? Then I go over here. Does this already include x plus 3? As a matter of fact, it does. So this whole denominator is already contained here, so I don't need to add anything else. Now, if this were x plus 3 times 7 or something like that, then I would say, yeah, I have the x plus 3, but I don't have a 7, so I would have to throw a 7 out front here. Okay, but it's not, there's not a 7 there, so it doesn't take a 7, this is fine. Okay, there's an x minus 5. Does this guy already contain x minus 5? As a matter of fact, it does. So I don't have to add anything else to this denominator. This is the smallest denominator that will contain all three denominators. Okay, so I make them all have this for their new improved denominator. So this is my goal, to make all three of these fractions have this same denominator. Well, here's the good news. this guy already has it. Look, I don't have to do anything to turn this guy, x minus 5 times x plus 3 into x minus 5 times x plus 3. It's the exact right thing. So the top just stays like it is. Nothing changes. But look what happens here. To turn this bottom, x plus 3, into this bottom, x minus 5 times x plus 3, what do I have to do to turn that bottom into that bottom? I have to times by x minus 5, right? Now, if I times this by x minus 5, then I will have this denominator, okay? But if I times the bottom by x minus 5, in order to keep this equal, I have to times the top by the same thing so that I'm just timesing by 1. So I have to times the top by x minus 5, which will give me 4x minus 20 right there. And then same kind of idea right here is x minus 5. What does it take to turn x minus 5 into x minus 5 times x plus 3? Well, I'm going to need an x plus 3, right? So if I times the bottom by that, I need to times the top by x plus 3. So I get 3 times x plus 3, which is 3x plus 9. Now, good news. They all have the same denominator. When they all have the same denominator, then I can just write it one time. And I can combine all the tops together. So look what I'm going to get. I'm going to get negative 3 plus 4x minus 20 plus 3x plus 9. So let's start with the x's. 4x and 3x. That's going to be 7x, right? And then negative 3 plus negative 20 plus 9. So negative 3 plus negative 20 is negative 23. Add 9 to that, and I get negative 14. Negative 14.
Yeah.
And then, oh my gosh, I can't believe the good fortune that's with me. Look, these both have a 7. So factor, now if they didn't have anything to factor out, you don't have to, but look, they both have a 7. X minus 2 over, oh my gosh. Wouldn't that be amazing? Wouldn't that be amazing if this was an x minus 2 instead of an x minus 5? Then would I be able to cancel those? Yes, I would. If these were both, if this was x minus 2 and this was an x minus 2, I could cancel them. But this is an x minus 2, this is an x minus 5. Can't cancel those. So there's my great and mighty answer. Not too tricky. Okay. How about this next thing? This one. Same idea. Factor the top. That's top. Factor the bottom, not the top, the bottom. Okay. So right here, the denominator. Okay. X, X. Two things that multiply to be 15, subtract to be 2. Holy moly. It's the same thing as there. It's going to be 5 and 3. Different signs, bigger one, minus. Okay. So it's the same denominator. Can you believe it? The fortune is with us. Okay. Minus x minus 5, x plus 3. Okay. Now, to turn this into this, I don't need to do nothing. Oh, one thing I didn't check is, look, does this guy contain this guy? Yes, it does. So I didn't need to add anything to it. Okay, to turn this into this.
You wrote negative, it's negative 32.
Oh, okay, thank you.
Yeah.
Negative 32, okay. Now to turn this into this, I had to times by x minus 5. So I times this guy by x minus 5, and I get 4x minus 20. Now, something interesting here. Something interesting here. Look, this is a minus. So, I'm still going to have a common denominator of this. But look what I'm going to get. Negative 32. Now, I need to distribute the minus to both of these guys. It's a minus sitting out here, so it's gonna be minus 4x minus minus is a plus 20. Be careful on distributing the minus sign. Anything that has a minus sign in front of it, you gotta distribute to everything there. And so now we get negative 4x on top. Minus 32 plus 20 is minus 12. Is that right? Minus 12? Yes. And then x minus 5, x plus 3. That's going to be, hey, these guys both have a 4, right? And the leading thing's negative, so I'm going to pull out a negative 4. Notice I'm not pulling out a negative because they both have a negative. I'm pulling out a negative because the first thing's, it only matters what the first one is. It doesn't matter what the second one is. So, negative 4. Now, negative 4x divided by negative 4 is x. Negative 12 divided by negative 4 is plus 3, right? Over x minus 5 times x plus 3. Wait a minute. This time, they do have something in common that I can cancel. And look what I get for an answer. Negative 4 over x minus 5. How about that? Can you believe that? Cha-ching. Okay, so that's adding and subtracting polynomials, rational expressions with different denominators. Okay, that was the stuff for the last couple of assignments. Okay, now, today's stuff is going to be solving rational equations. That's the difference. We haven't been, notice, this does not have an equal sign. This does not have an equal sign. It's just an expression that we either add or subtract together. However, this one, the one I'll bring up here, which is what I have written on the board here, that guy right there does have an equal sign. So how do you deal with that? Well, you deal with it similarly to how you deal with adding and subtracting these guys. You look at the denominator and say, what is the least common multiple of the denominator? Now in this case, the denominators are x minus 3 and x, right? So if I ask you what they have in common, some people are going to say x. They have an x in common. And that is not correct. They do not have an x in common. This guy has an x. X minus 3 does not have x as a factor. Let me give you an example. What if x is 20, right? Well then 20 minus 3 is 17, right? 17 doesn't have 20 as a factor, so it's not that way. What it means to have it as a factor is it multiplies into it evenly or divides into it evenly, not adds or subtracts. So actually, x minus 3 and x don't have anything in common other than 1. Everything always has a 1 in common. But these guys don't have anything other than 1. So in order to get their least common multiple of the denominators, I would have to multiply them together. So what I could do is make both of these denominators have x times x minus 3. I can make that as the denominator. But I've got a better idea. Instead of making it be the denominator, I'm going to instead multiply both sides by that. Okay? I'm going to multiply both sides by x times x minus 3. I'm going to give me a little room here. Okay, so what happens when I multiply? I'll show you. Okay, so here's what I'm going to do. X times x minus 3. I can put it over 1 if I want to. I'm timesing my x times x minus 3 over here. Now, what's going to happen when I do that? Something interesting. Look, this is multiply, right? Remember, 1 on the top and 1 on the bottom, you can cancel those. So I'm just going to get 3x, right? This x minus 3 cancels with this denominator. The denominator goes away and turns into 1. I get 3 times x. Okay, what happens over here when I times these together? Well, the x's cancel, and I get equals 2 times x minus 3.
Something that's important to note is that the reason he's allowed to put it over 1 is because it's an equation. So in the other ones, you had to multiply by the quantity over the quantity. You get what I'm saying?
Yeah,
But in this one, because it's an equation, if you're multiplying both sides of the equation by the same thing, it's okay.
right.
Yeah.
That's correct. Yeah, because, yeah, over here, we multiplied the top and the bottom by the same thing, so we were timesing by 1, right? Over here, we're timesing both sides of the equation by the same thing. So that's, yeah, that's the difference.
Yeah.
Okay, so now, we distribute the 2, 3x equals 2x minus 6. I want to get x by itself, so let's see, I can move this 2x over by minusing 2x. That gives me x equals negative 6, and I got it. This is my potential solution. It may or may not be a good solution. How do you know if it's a good one or not? You take that answer, x equals negative 6 in this case, and you plug it back into the denominators. It can't make the denominator 0. If the denominators are 0, then you're dividing by 0. Bad. We all know what happens when you divide by 0. Bad news. So you plug this in and make sure it doesn't make any of the denominator 0. So negative 6 minus 3 is negative 9. That's not 0, so that's okay. Negative 6 by itself is not 0. So this is a good solution. That's how you do that. Okay? Now, we're going to do this one next, but I'm going to erase to give me some room to work. It's the same idea. The next few problems are all going to be a similar idea as to what I just showed you. And we'll do a few more of those. So just hang in there. Okay, so this guy right here, 1 over x plus 3 over 2x equals 2 over x plus 1. Well, let's look at the denominators. X, 2x, x plus 1. What is the smallest thing that contains everything? Well, I just start with a denominator. Start with x. I'll do it over here. X, okay? Then I go over here, 2x. Does that have a 2x in it? No. Well, do I have a 2? No, I don't have a 2, so I need to throw the 2 in. Do I have an x? Yep, I've already got an x, so I don't need to throw in another x. So far I've accounted for both of these guys with 2x. 2x is the smallest thing that will contain this and this. Now I go over here. Does this guy 2x have an x plus 1 in it? The answer is no, it does not. So I have to throw in an x plus 1. So x plus 1. So now, this is the smallest thing that will contain all 3 of those denominators. Now you want it to contain all 3 of those denominators so that when you multiply it by each of those, it will wipe out all the denominators. If you multiply by something, I'm not doing this to make all the denominators the same, to make them into this. Instead, I'm going to multiply both sides of the equations by this, and it's going to cancel out the denominators. Let me show you. I get 2x times x plus 1, right, over 1, times, same thing here, 2x times x plus 1, the whole thing over 1. Now, watch closely what I'm doing here. Watch. This x cancels with this x, leaving me with 2 times x plus 1 times 1. Okay? So look, this x cancels with this x. They both turn into 1s. This gives me 2 times x plus 1 times 1 times that guy right there. So that's just 2 times x plus 1. That's what I've got, over 1. So you don't even have to put over 1. Okay? Plus, here, now this whole thing comes back this time because the canceling, whoa, I thought that was my eraser. Hang on, that's crazy. Okay, I'm going to erase this and make this 2x. So here we go. 2x times x plus 1 over this. Now I'm timesing it by this guy. Look what happens now. This whole 2x cancels with this whole 2x, and I get x plus 1 times 3 plus x plus 1 times 3. I'll call that 3 times x plus 1, right? And then equals, look what happens here. The x plus 1 cancels with the x plus 1, and you get 2 times x is 4x. If you do it right, if you pick the least common multiple of the denominators, then the denominators always end up canceling, just like they did here. You're going to see that in the next couple of problems we do. The same thing's going to happen. The denominators are always going to cancel. If you multiply by the least common multiple of the denominators, that always happens. So now, distribute this. 2x plus 2 plus 3x plus 3 equals 4x. Now, I'm going to simplify this side. 2x and 3x is 5x. 2 plus 3 is 5 equals 4x. Okay, I want to solve for x, so I'm going to move the x over by minusing 5x from both sides. That gives me 5 equals negative x, or negative 1x. I need to solve, so I'm divide by negative 1 to get rid of the negative in front of the x. That's going to be negative 5 is x, which is my potential solution. Okay, now, does negative 5 make any of the denominators 0? Doesn't make x 0. Doesn't make 2x 0. And it doesn't make negative 5 plus 1 is also not 0. So it is a good solution. There it is. Okay, got a couple more to go for you. Here we go, this one. Okay, x minus 9 over x squared minus 9. Equals negative 3 over x minus 3. Okay, there we go. Now, you might think, wait a minute, I could cancel these 9s, but that's not right. In fact, if you cancel these 9s, you are a home wrecker and a kitten killer, right?
Oh, wow.
Can you zoom in on that for me? Okay.
Zoom in on what?
Right there, kitten killer. Every time you do this, a kitten dies. Don't do that. Don't do, see how they just canceled the x squareds, right? Canceling the 9s is like that. Why? Because they're stuck with pluses or minuses. You can't cancel things that are stuck with pluses or minuses. You can only cancel things that are separated by multiplication, right? So if you tried to cancel these 9s, you would be not a home wrecker because these guys are happily married and these guys are happily married, but you came along and messed it all up. Or because you would be a kitten killer. You'd be a home wrecking kitten killer. Please don't do that. Nobody likes a home wrecking kitten killer. Okay, so please don't. Okay, so here we go. Now, oh my gosh, you know what this is here? This is a dog. This is a difference of squares. Check it out. X plus 3, x minus 3. I can't believe it. So, what is the least common multiple of all the denominators? Well, it has to have x plus 3 and x minus 3. If it doesn't have both of those, it won't contain this guy. So it has to have those. And it also has to have x minus 3. Does this already contain x minus 3? Yes, so I don't need to throw another one in. So this is my least common multiple of my denominators. So I'm going to times both sides by that. I'm going to times them by x plus 3 times x minus 3. Okay. On this side, I'm going to do x plus 3 and x minus 3, right? You can think of them as being over 1 if you want. The reason I put it that way is so you realize these are in the numerator upstairs, able to cancel with this denominator here. The numerator here, able to cancel with these denominators here, okay? So here's the deal. Let's cancel. Oh my gosh, this whole thing cancels with this whole thing, and look what I get, x minus 9. This whole thing wipes out the whole bottom, and we get this, equals, okay? What happens over here? This guy cancels with this, so this whole bottom goes away, and I get negative 3 times x plus 3. Like that. Now, it's not too difficult. Distribute that guy, and we get x minus 9 equals negative 3x minus 9. Well, wait a minute, that's interesting. What's that going to lead to? Let's find out. Add 3x to both sides. I'm trying to get the x's over to this side and the numbers over to this side, but oops, it's like that squirrel that runs in front of your tires. Splat. I didn't mean to, but hey, he ran in front of my tires. Not my fault. X and 3x is 4x equals 0. 0? What? 0? It's just a number, people. Calm down. Okay? How do I get rid of times 4? Divide by 4. Uh-oh, what's 0 divided by 4? Oh no, is that evil? No, 0 divided by 4 is not a problem. 0 divided by 4 is just 0. It's 4 divided by 0 that would be the problem. 0 divided by 4 is just 0. That is different than no solution. 0 being a solution is different than no solution. And I do need to check it and make sure it doesn't make any of the denominators 0, but it doesn't, so it's a good solution. All right, that's how that works. Let's see, we might have one more here. Good, we do. One more. Okay. See if you follow this. Okay. It goes 2 over a plus 1 plus 1 over a plus 1 equals 4 over a. Okay, here's the deal. Now these both are the same, a plus 1 and a plus 1. So I could actually combine these together and make it 3 over a plus 1. In fact, that'd probably be the smartest thing to do here. 3 over a plus 1 equals 4 over a. Okay. So the least common multiple of these, a plus 1 and a, remember, they don't have anything in common other than 1. Everything always has a 1, right? So their least common multiple is just going to be multiply those things together. So it's going to be a times a plus 1. And over here, same idea, a times a plus 1. Now, what's going to happen? It's going to be, watch, the a plus 1s are going to cancel. And I get a times 3, which is known as 3a, equals, these a's cancel, and I get 4 times a plus 1. Now, I want to point out something. Whenever you have a fraction equal a fraction, that's called a proportion. Then what you can do, what's equivalent to multiplying by the least common multiple of the denominators is cross multiply. Notice, if I cross multiply, I'm going to get the same thing. But that only works if you have a fraction equal a fraction. If it's like this, where there was 2 fractions over here and 1, and these didn't squeeze together, then you would not be able to cross multiply. You can only cross and multiply when it's a fraction equal a fraction. When it's more complicated than that, cross multiplying doesn't work. But here, when we got to this point, it was a fraction equal a fraction, so you could cross multiply. Look, 3a equals 4 times a plus 1. Look what I got. 3a equals 4 times a plus 1. Same thing you'd get if you cross multiplied. Okay, so we get 3a equals 4a plus 4, minus 4a from both sides. Negative a is going to be 4. Negative a equals 4. But I'm not really interested in negative a. I don't care what negative a is. I care what regular A is, so divide by -1. A is -4, and there we go. Oh, not there we go. We got to check and make sure it's not a bogus root. Okay, look, -4 plus 1 is -3, that's good. That's -3. -4 there, it doesn't make any of the denominator 0, so it's a good solution. So there we go. All right, one more. This is our last one. Okay. Let's see, 4 over n, oh, wait a second. I'm gonna write it like this. 4 over n squared equals 7 over n plus 2. Okay. Well, 2 doesn't even have a denominator. You could put it over 1 if it makes you feel good, right? 2 over 1 if you want it to have a denominator. So now, this is n squared, this is n. Obviously, n is contained in n squared. So n squared turns out to be the least common multiple of all these denominators. So what I'm going to do, instead of making them all have n squared as a denominator, I'm going to multiply everything by n squared. When I say everything, it's got to be n squared times this, and this, and this. It has to be everything in the equation. So here, the n squareds cancel, and I just get 4. Here, this n cancels with one of these n's, but not both, giving me n times 7 is 7n, plus, now the n squared came back, n squared times 2, nothing cancels here, so it's 2n squared. So there's my second degree equation, my quadratic equation right here. Now, what happens when I have a second degree or higher, a quadratic? I try to make one of the sides 0, and I want whatever's in front of my square term to be positive. It's already positive, so I'm going to move this side over. I'm minusing 4 from both sides. We're going to get 0 is 2n squared plus 7n minus 4. So I got it equals 0. Now, I'm going to pray that this thing factors. Please factor, please. If it doesn't factor, I might cry. Okay, let's see. Let's see if it factors. 2n, okay. Oh, look at this, 4 and 1. Oh my gosh, 8n, the oys, 8n and 1n. Subtract to be 7n, yes it does. Bigger ones plus, so the 8 has to be plus, the 1 has to be minus. That's what it factors into. And remember our shortcut. To make this equal 0, n equals the opposite of this over this, positive 1/2 and -4, which are my potential solutions, right? Do either of these make any of these denominators 0? No, they don't, so they are good solutions. They're both good solutions. There's 2 answers to that problem. Okay, so this is your, right here, this is homework number 39, page 676. This is out of your textbook, page 676, 3 through 19 all. Enjoy. Man.